We're going to go ahead and get started. Hi, everyone. Thanks for joining this session. So today we're going to talk about the data science, overall job market, and I'll talk about the career guide. So if you're interested in getting into data science, WeCloudData has just published our 2023 data science career guide. I will share the link with everyone in Zoom. Yeah, I would like to walk you through this career guide. But I'd encourage you to read it yourself. It's pretty long. I won't spend a lot of time on it today. I'd rather spend more time so that on the AMA. So if you can ask me any questions, questions about data science career, learning path, or the current job market, interview. If you have your resume ready, I'm happy to review it. Casual chat, so no formal presentation today. Yeah, send your question. I'll be around for an hour and a half. So feel free to you can even go ahead and share the screen. I'm happy to look at your project and resume as well. Okay, but first of all, let me quickly guide you through the WeCloudData career guide for a data scientist. And here is the link. So this career guide is broken down into 6 to 7 different posts. The first one is about data science. So what is data science? So this is a pretty long article that introduces, data science, the data science life cycle. There are 2 pretty popular ones in terms of, data science life cycle, right? One is called CRISP. That's sort of have been used as like an industry standard for many, many years. You'll see different variations of this. I would highly recommend you follow this, approach when you start to build your portfolio project, right? Or any kind of data science project you build. It typically starts from the business understanding, right? Even this has been coined like probably 20 years ago. It's still true as of today. You always need to have a business question, right? And a business problem you would like to solve. And then the business will ask, if the company is data driven, then they will ask the data team or IT, do we have the data to support, right, this kind of business decision making or to help the business solve the business challenge? And once you understand the data or understand where data come from, then you have to ingest the data, start to do data preparation. And at the data understanding stage, we assume that the data is already available, right? Prior to that, you probably need to do the data collection and ingestion. And then data scientists will need to build scripts to prepare data. And it's probably the data engineers who are going to help automate that data preparation process. Once data is prepared, right, that probably includes feature engineering as well for machine learning, right? And then data scientists start to do modeling and then move on to model evaluation. This could be evaluation based on historical data, but in some companies, for example, in the banks, when they evaluate models, they probably need to wait a couple of months to have a champion and challenger model so that they can compare the results to make sure that the model validates well out of time as well, and it's future proof, right? And then the model will be deployed. Now, the evaluation and deployment, including the modeling part, these can be done by machine learning engineers if the company want to deploy the model in real time in production, right? If you just want some sort of batch prediction, you probably just need, data engineers and data scientists to help you, to automate that workflow using Apache Airflow or using some sort of Lambda functions or Spark jobs. So I think over time, the data science job has been sort of become more specialized. So I think in the past, data scientists probably just need to focus on data understanding, preparation, and modeling. But now some data scientists are actually just focusing on the data analytics part. They're statistical analyst or data analyst. And some data scientists working for big tech companies such as Facebook, they actually don't build a lot of machine learning models. They're work more closely with the product team to do ad hoc data analytics. They build a lot of, A/B testing, and they have to use like statistical analysis to analyze the results, right? And someone who's building deep learning, large language models, they are actually more like research scientist or NLP specialist, right? People who focus on the model deployment side, now they're called machine learning engineers, or even MLOps. So they're like more like DevOps with machine learning knowledge. I think this is a good thing. So you can't really expect one person or data scientist to understand or be specialized in everything. So but regardless, I think this crisp whatever methodology or approach still works pretty well. And Microsoft also has its own version, which I think is similar. So I won't go through this one. You can click on the link here to go to the actual documentation. And of course, there are a lot of new use cases of data science, machine learning. I think the most recent hype is ChatGPT, right, which is generative model AI based on large language models. It generated a lot of hype. I think at this point, I hope you guys have all experienced it already. I think it works really well if you want to use it to generate, for example, sales script, to do creative writing. I don't think it's going to completely replace those kind of jobs, but it definitely helps save time. So yeah, look into that. It has Python API as well. You can work with OpenAI, but looks like you have to pay now. But I think if you work as a developer, or you come from that background, or you want to work as an ML engineer, it'll be interesting to deploy some of the chatbot that actually leverages ChatGPT. So let's always think about how to build applications and put that to use, right? But in terms of the technology itself, I've sort of been following some of the deep learning neural network giants, and the head of AI at Facebook doesn't seem to be a big believer of the technology because he thinks that ChatGPT is actually not that smart. So I read all kinds of like reviews and debates online. It's kind of fun sometimes. But definitely, I think it's time, very exciting time to learn more advanced, techniques. So I think data scientists will need to adapt as well. But ChatGPT is a very special NLP use case. I think in computer vision, or even just in the traditional businesses, machine learning has been used more and more to solve real life data challenges. So that's very, very interesting. Okay, I listed some use cases here. For example, how data science can be applied in healthcare, in VR, AR, even in Web3. WeCloudData has real-time projects. Some of you may know that already if you have attended past events. And recently we started to work with Web3 company. But I think, even though the core technology is based on blockchain, but they're still doing very traditional data analytics, right? You still need Python, you still need Tableau or Power BI to do all kinds of visualization, but it's really interesting data to look into and analyze. There are a lot of interesting use cases in digital and media as well, fintech, e-commerce, you name it. It's being used everywhere. And also we worked on some sports analytics project. So yeah, take a look at it. And there's some links to a blog post that actually discuss these projects in detail. Hopefully that can give you some inspiration when you start to work on your own portfolio project. So this is the first article explaining what is data science. I think, we actually talk more about the actual data scientist job on the second in the second article. Typically when it comes to data scientist, you need to know, this is the Venn diagram. You probably have seen that many times. You need to know programming, math, machine learning, and also storytelling. So I expand on that a little bit and help you understand the different types of data scientists and the skill sets required. So hopefully you enjoy the reading. And then I also explain the differences among data scientist, analyst, and data engineer. I encourage you to read this, but just briefly to go over this. I think if you look at the crisp, whatever data science, end-to-end diagram process, usually business, when they have a data challenge or business challenge, they will start from data, right? The first question is, do we have the data? So that's where data engineers would come in and help the company collect data. The IT systems and whatever applications the company use or work with have generated data already. So the data engineers, most of the time, they will be ingesting those data, whether it's from the website, right, company's web application, or a SaaS, tool such as MailChimp, Salesforce. Companies will typically be dealing with like 10 to 20 different kind of data sources. A lot of companies will be dealing with way more data sources. So data engineers will need to ingest the data. Sometimes they have to encrypt the data and also mask some of the columns, right, for privacy issues. And they have to follow some sort of best practices. And then data engineers usually work on data quality, data transformation as well, right? So that process may take months, but it could be pretty quick as well, depending on the use case. And then we need to sort of explore the data, right? Data exploration can be done by data analysts and data scientists, but they do that for different purposes. Data analysts in an organization typically do ad hoc data analysis, right? So they work closely with the business, and the business usually have assumptions. They're like some kind of business questions they would like the data analyst to help them answer by analyzing the data. So part of it is data visualization, right? Data analysts don't build dashboards every day. When it's necessary, they will need to build dashboard, of course, but most of those analysis could be ad hoc analysis using SQL, using Python. And of course, like SQL and Python are just coding languages to work with data. So how do we present the results to the business? A lot of times it's surprisingly, it's actually Excel, right? Because whenever you share some file with the business, Excel is usually preferred because you can summarize everything and put in a PowerPoint, but sometimes the business will actually prefer to access the raw data so that they can sort of work with the pivot table and slice and dice themselves. That's actually quite helpful. And also keep in mind that, the business users, they will be building presentations for their bosses as well. So they sometimes would prefer to just use Excel to draw the diagram, and then they will, they'll work on styling everything to make it fit for their presentation. And of course, if they're analysis that can be reused, it's time to think about building a dashboard. In that case, Power BI, Tableau, Looker, these are probably three of the most popular visualization solutions out there. But some companies will purchase more expensive solutions such as Click. Yeah. So that's what the data analysts do, a lot of ad hoc analysis and then building dashboard. Sometimes these are, BI person or the BI developer building dashboard as well, but that involves more data modeling. So you do need to sort of set up the database in a way that it's easier for data analysts to query, right? This is called analytics engineers as well. So yeah, data engineer, analytics engineer, whoever who's good with workflow automation and SQL data modeling, that's actually a very popular role. And data scientists will typically, use Python and SQL as tools to do more advanced data analytics, right? So they're probably going to aggregate the data in a slightly different way, right? But they'll be looking at time series patterns, right? They'll be training machine learning models to do customer segmentation or build predictive analytics, right? So that involves machine learning, more advanced data aggregation or whatever data manipulation skills. And most of the data scientists deal with structured data, even though 80–90% of the data on the web are unstructured data, but I think most of the data that has been worked on are actually structured data, right? Because they are typically stored in some sort of databases. And data scientists will be working with structured data and use packages such as PyTorch or scikit-learn to train machine learning models. And if you would like to get more specialized, then deep learning engineer or computer vision scientist or NLP specialist, they'll be using PyTorch to work with unstructured data such as image data, video data, and textual data, right? So they'll be doing sentiment analysis. large, like ChatGPT is one of those, but the training cost is really, really high. So most of the company, well, I think majority of the company would not be able to afford it. And I think the reason why OpenAI is able to do that is because Microsoft is, supporting all of these research, right? So yeah, that's a quick explanation of the differences among different kind of data roles. And you can read this in more detail. Now, after you understand what is data science, what does the data scientist do, I think you also need to decide if this is the right career path for you, because we've worked with many students in the past that, and sometimes when they go down this learning path, they realize that they're actually not that passionate about machine learning and statistics and math. So a lot of them will actually try to focus on data analytics, and some of them will find passion in data engineering because they feel like coding is actually more interesting and challenging. In terms of the career path, I think that's something you have to think about before you get into any kind of new career, right? You always start from a more junior intermediate level data scientist, but you can work your way toward a senior staff data scientist position. So lead, senior. You don't really need to have a manager title in order to lead, right? So a lead data scientist is a lot of times involved in hiring decisions as well. So you'll be given interviews and give team direction as well. Well, if you're interested in going down the technical path, I think this is a pretty good direction, and then you can consider becoming a machine learning engineer in the future as well. And the skills are pretty much related. I've started to see data scientists going down the data engineering path, and data engineering is indeed a very exciting path right now. I think it's because a lot of companies realize that they need more data engineers to figure out the data, right? Because they're collecting more and more data and different kinds of data. Ever since COVID, a lot of companies would like to building their online presence, right? So they start to spend more money on Google ads, Facebook ads, and that's actually one of the reasons why these companies are cutting jobs right now, because they grew too fast during COVID. They pretty much doubled their team. And but now we are post-COVID. Companies are starting to invest their marketing budget on offline activities as well, right? So it's not really only spending money on Google and Facebook ads, and of course the revenue will be challenged, and companies start to cut jobs. It's not because they're not doing well; it's just because they grew too fast during the COVID. But my point here is that if the companies start to build their online presence, they will want to collect more data. They'll definitely want to understand the customer behavior better. That means they need to collect first-party data from their website, right? Web analytics data, user activities. And that means companies will want to ingest data from, using Google Tag Manager, for example, right? Using tools such as Snowplow. And companies would like to collect data from their SaaS tools that they might be using, Apache Airbyte, Fivetran. So ingesting all of these data into the data lake and warehouse, right, and then build some sort of workflow to transform the data and use the transformed data for any kind of analytics purpose. This all depends on the data engineer. Before this happens, I don't think data scientists will even have the data to build machine learning models, unless it's unstructured data, right? Most of the structured data you still need to go through some sort of ELT process. So yeah, data engineering is pretty hot right now. I see data scientists switch into data engineer. Not at a massive scale though, because usually people working on data science and engineering are different types of people, because data scientists like to work on business challenges, like the business rules is something of interest to them, right? You accumulate more industry knowledge. But I think data engineers are folks who are passionate about solving challenges, improving the efficiencies of things, and make your code or more scalable, right? Dealing with bigger data set, working with different tools and platforms. That's quite different. And of course, you can go down the managerial path, right, to become manager, director, VP. And that's a typical career path for any kind of jobs. Yeah, take a look at this guide. In product management, there are a lot of data scientists, especially in the big tech company. They eventually move on to a product manager role. So they sort of own a piece of the software application, or they own some sort of data, and then they have to work with different teams, right? Work with software engineers, product, business, as well as the engineering team to build some really cool product features. And you'll find more product manager, product owner jobs in big tech companies or startups. Consulting is a really popular career path for data people, right? Whether it's data engineering, data science, and analytics, because there's so many business out there that will need expertise from data scientists. It doesn't necessarily mean joining McKinsey or Deloitte or Accenture. There are a lot of boutique consulting companies out there. A lot of people just start from freelancing, and then they start to grow their small boutique shop. And it usually works very well as well. So think about these, and I hope you can find the right career path for yourself. Once you figure out the career path, you understand what this is about. I think you probably need to do some research on the job market as well. That means you need to understand the kind of skills required, right? The job demand by geolocation, the requirements, how many junior jobs out there, how many senior jobs out there, what is the salary like, the competition, and also growth opportunities. So yeah, spend some time to read this. It's pretty detailed. For example, for experience requirement, looks like there are actually more junior data scientist job demand compared to than the demand for data engineers. Data engineers usually require 3 to 5 years of experience. And because you need to work with a lot of different tools, and data engineers will help make a lot of the decisions, right? So experience is important. Otherwise, if you're not very experienced, then you end up wasting company money and going down like a very ineffective, route. But looks like for data scientists, 34% asking for 5+ years of experience. You still find a lot of jobs requiring 1 to 3 years of experience, which is good. That means there are more junior jobs out there, but there are also more junior data scientists competing because there's so many schools providing data science training, and you're competing against people graduating from computer science, the traditional statistics department. So having a little bit of experience is definitely going to help you. Yeah, and I have some salary information. I think everyone knows that data scientist is one of the most best paid jobs. So I won't spend too much time on this. And then learning path. I think learning path is important. You need to understand what's the most important thing to learn. There are a lot of guides out there. I think most of them are similar. When it comes to the things you need to learn, it's pretty much the same. Everyone understand that you need to be really good at Python, SQL, right? You need to understand big data, understand machine learning, right? So I share some of these details in this article, but keep in mind that the fundamental skills are actually more important sometimes, because when you go to interviews, most of the time company will give you a Python challenge or SQL challenge. So make sure that you don't fail this kind of challenge so you can move on to the next round, actually get to talk to the team and hiring manager. I think that's very important. And that's why a lot of people do lead code. But not every data science job will require lead code. But absolutely, most of the data science interviews will require SQL and Python. Okay. I would definitely recommend learning Apache Spark and learn a little bit cloud, such as AWS, Azure. Most of the job referral opportunities we have, like the employers will be asking for some cloud experience, and some companies will need big data skills as well. So make sure you invest some time in it. Okay. All right. So after you've learned all of these skills, I think building portfolio project is important. Right? You can watch some of these videos. So it's pretty long. It's really just a quick summary today, and I would like to leave more time for questions. Building portfolio project is important. Without a portfolio project, I don't think you you will be able to find jobs in data science today. Unless you come from like a computer science, you have PhD or master. Like a lot of master of data science folks, graduates, they are having challenges, even landing interviews because the market is very crowded. So I think you need to have pretty decent portfolio project in order to impress people. And having one portfolio project is not enough. I think you should have at least 3. Right? I used to say 2 to 3, but I think you need 3 at least. And make sure they're not the same. If all of them are just using decision tree regression to do some sort of supervised models, it's not very helpful. I think you need to show a variety of skills, right? Maybe one project is about unsupervised approach, another project is about supervised learning, and maybe you can have another project focusing on natural language processing, dealing with unstructured data. And for most of these portfolio projects, it will be great if you can show your ability to pre-process data, right? Even collecting the data on your own, I think that's very important. I would definitely recommend starting with a domain first. Decide what type of problems you would like to work on first, and then go find the data set. If you can't find the data set that will make you happy, then just go collect the data yourself, right? Whether it's data collected from Twitter or some other website through web scraping, it all shows that you have very good data skills, right? Because as you know, even ChatGPT can write some Python, scikit-learn code. So these are boilerplate code. If you're proud of that, I don't think you'll be able to find a data scientist job. So you have to show that you have the ability to write the code, to collect data, to store data, to ingest data, even for a data scientist job. Even though that's not what you're going to be focusing on in your real data scientist job after you get hired, but you want to show that skill, right? So that means, when you actually work in a data science team, you'll be able to collaborate well with the data engineers, with IT people, with software engineers. Visual storytelling is also important, right? Sometimes the things we build are pretty abstract. Can you visualize it, right? I tell a really nice story. So that means data scientists might also need to build some Power BI dashboard, but it's not really a BI dashboard just to show some metrics. It's a dashboard to explain your machine learning model. I think that would be very effective, right? And of course, step 3, all of these magic in machine learning, well, you want to make sure that your code looks really nice, right? And so people sometimes may actually check out your GitHub repo, for example. So make sure you follow the best practices, right? And don't just borrow the boilerplate code, which is pretty standard. That's the part that should be automated. Okay. All right. So I have some examples here. If you have some sort of workflow diagram, the end-to-end pipeline, make sure you show that, right? You not only want to show people this is the project you built. For example, this is one of the portfolio project our students built. They were trying to do some real-time Twitter sentiment analysis and use that for stock price prediction, right? So they collected data from Twitter. So this is working with the Twitter API. They also worked with other API to get stock price data, I believe. And then they did everything on Amazon EC2. So that means they set up the infrastructure, right? And then they run a bunch of Python script to collect data. For Twitter, they did sentiment analysis, and then they used the sentiment prediction as one of the input into their time series forecasting model. And the time series data is stored in some sort of NoSQL database, right? They tried like Facebook profit package. They tried some sort of deep learning LSTM models and write the results back. And they also visualize the results in real time. So that is a pretty cool project that involves some sort of ML engineering and data engineering skills as well. So that's a project I would highly recommend, but definitely don't. Most of the project I've seen, they only focus on one thing. They train a bunch of models, but there's no infrastructure layer, there's no data pipeline, there's no visualization, there's no data collection. So you can find a lot of examples, but you won't find a lot of end-to-end example like this in the job market. And that's why students with this kind of portfolio will be able to get more attention, right? It's not really guaranteeing a job because interview skill is also very important. So speaking of interview, I think job search preparation is very important, right? So you need to understand how to build resume, check out the video here, and make sure you put the relevant keywords on your resume, right? I think now that you have ChatGPT, you should probably leverage that to write some, template resume for you. I've seen some interesting examples out there. It's a good starter, but I don't think you should be relying purely on ChatGPT. You definitely want to tailor the resume, but I believe it's going to save you some time, right? But when you put these keywords on the resume, you want to make sure that you actually own these skills and you can explain it very well in an interview. And you want to make sure that you have the experiences that match those skills, right? So a lot of employers will be, if you show them 10 keywords, skills, they will want to see those skills in your experience, right? If you list Apache Spark and AWS as keywords on your resume, but if the people can't really see in your work experience or in your portfolio project, that means these keywords are not, it's kind of fluffy, it's not very useful, right? So make sure you do that and try to learn a lot of business use cases because you're probably going to join a marketing analytics team working as a data scientist, or you might be joining a sales compensation team to do some sort of modeling or HR. That's why I suggest starting from a business domain first. Pick a domain and then find the data set, right? So you always sort of start with a business problem before you start to build your project. But learning different use cases will be very useful. And yeah, in job application, it's all about preparation. So I have a lot of details. Hopefully you can find something useful for yourself. Okay, so that's a quick walkthrough of WeCloudData's data scientist career guide. Again, I will share the link again with you, and I hope you find it useful. Now, I think it's time to move on to the AMA session. So if you have any questions, feel free to ask me. It could be any questions. As I said at the beginning, if you have a resume you would like to share, I'm happy to provide some suggestions. And yeah, it's time for you guys to ask questions. There was a question from Brandon. After learning SQL and Python, what are some projects you can do? And what level of coding do you think will be needed to understand it? Yeah, I think after, well, first of all, when you're learning SQL and Python, I think you already need to start working on projects, right? For SQL, the best project that goes with SQL should be some sort of visualization dashboard project, right? So if you're building SQL, that means you're extracting data from a database, then connect your Tableau free license or Power BI or Looker, or even open source visualization tool, connect them to the database and build some visualization dashboard, right? So that could be a really good project, data analytics project for SQL and visualization. For Python, if we are not talking about machine learning, only just the Python part, I think you should be working on some sort of data collection project, like such as web scraping, working with ChatGPT, for example, right? Work with the OpenAI project. So you sort of have to think about what kind of project you can build, right? And maybe you can build a chatbot by leveraging the API. But it doesn't mean like you're the person who's able to build the chatbot. You're really just leveraging the OpenAI API. But that helps you to improve your Python programming skill, right? And it looks interesting as well. But later, I think you'll need to sort of learn machine learning, and then you have to work on different kind of machine learning projects. Okay. Do we have access to this file? This is not really a file, it's just a Notion page. I can share the link with you again. And if you're talking about the career guide, let me share the link with you so you can access the career guide. Yeah. Question from Shah. what are some new technologies that companies are looking for when it comes to data science? Okay, so new technologies. I don't think they're like super new technology. They're probably new, in machine learning, there will be new algorithms, right? Coming out every day, large language models. But I think you're not going to apply those on a daily basis. It really depends on which industry you go into. If you're going to work for a supply chain company, you're most likely going to be working with time series forecasting problems, because they have a lot of demand forecasting problems they would like to optimize. If you work for a bank, then customer segmentation, a lot of the marketing models, understanding customer behavior, customer analytics, or risk models, loan approval models, or those are very structured problem, right? So there's one thing that's relatively new, which is, but it's also related to data engineering. I think the modern data technology. So it's nothing to do with machine learning, but the modern data stack sort of is, making like SQL cool again, right? Because in the past few years, I think Spark and big data have been really popular. But modern data stack, things like Snowflake, DBT, and some of the new data ingestion tool work together pretty well. A lot of companies are using these technologies. So, and I think, data scientists, it sort of gives data scientists the opportunity to work with SQL to do a lot of the heavy lifting data processing instead of relying on Spark or Python. So you can just do that in SQL, and you can automate the workflow pretty easily. That's something worth looking into. But I think it's something data scientists need to know, but you're still going to focus on the analytics part instead of just, dealing with data, like data ingestion and data modeling. And of course, another exciting technology is definitely the large language models, or just deep learning in general. I think AI and deep learning development is at a point where you actually need to burn a lot of money, right, to get really decent model. Like generative models such as transformers, transformer is not generative model, but it's based on transformers, right? Google's transformers. And then the GPT-2, GPT-3, 3.5, and GPT-4. I think these models, their parameters, are just exploding. And it's almost impossible for a regular business to be able to train those kind of models. So one trend is the foundational model, which means the big companies will be training those foundational models like GPT-3, and then the entire industry are probably just leveraging that, right? Pre-trained models to do fine tuning, to tailor that to their own business problems. I think that's definitely going to be the trend. And that's something I think you need to pay attention to when you start to learn machine learning and deep learning. However, I would like to say that the traditional and classic machine learning, algorithms are still very useful. You don't always need to use those, cutting edge models. It's not going to give you a big advantage in a lot of the real life problems. Like I've been working with instructors who, like lead data scientists, building a lot of the computer vision problems, solving computer vision challenges for mining companies, for example. And he's been helping the companies save like millions and millions of dollars by building computer vision solutions. And among the 3 projects he built, he said only one of them are deep learning based. The other 2 are just regular computer vision projects, and they use a lot of OpenCV, not necessarily always going to train a deep learning model. And they even tried deep learning models, and sometimes it didn't work out better than it was, like performance is worse. So, and the practical problems are always, we always have constraints. Do we waste more time and money on tuning the models, or should we just go with a different approach that just works, right? Okay. Question from Monica. Is a master degree required to be a data scientist? I think it's preferred, but I definitely don't think it's required. In our data science bootcamp, 30% of the students have a bachelor's degree. 30 to 40%. The rest of them have master degree. I haven't seen master students coming from master degree background getting jobs faster, to be honest. It all comes down to, well, first of all, I should say their master degree is not in data science, of course. Otherwise, they wouldn't consider bootcamp. But I think when it comes to career switch, I think unless your master's in computer science, if not, then I would say it's pretty much the same. And company will only look at your your practical skills, like the kind of projects you built, and your past experience is also useful. If you have worked in project management, leadership positions, a managerial position, I think these are helpful because there's the soft skill side of data science is very important, right? Yeah, my answer is that it's not required, but it's definitely nice to have. You're always going to have some sort of advantage if you have a PhD. But people who don't have master degree, you can absolutely get a data scientist job. But I would like to warn you, right now the job market is pretty tough, right? It's not because the demand has decreased, it's just because a lot of positions are on hold and tech companies just cut a lot of people. So the market will need time to absorb these talents. What I can tell you is that I have some friends working at Twitter. Ever since they got laid off, they got a lot of offer, but interestingly, they didn't even take the offer. Some of them, like one of them started his own company, and the other is still traveling in Europe right now, taking a break. So we're not necessarily competing with these people because they have 2-3 years of experience working at big tech, or even more years. So their salary is pretty high, right? But for most of us here, we're probably just considering career switch to data science. So there's the market for us is definitely there, because the market is trying to absorb more senior talent. And at the meantime, because of the uncertainty, the opportunity for junior level positions are definitely, it's definitely, affected at this point, but the market will definitely come back. It's always like that. So can data analytics be a prerequisite to a career in data science? That definitely helps, Emika. So I wouldn't say that, if you work as a data analyst, right, compare someone who's switching directly to data science, I think you will have some advantage, but it's not a huge advantage because your advantage is that you have SQL and some sort of data analytics experience. So you have better instinct when it comes to better skills when it comes to data analytics in general. But most of the companies hiring data scientists require more advanced skills. So for someone who work in BI and data analytics, they don't build machine learning models on a daily basis. So the most desired and required skill in data science, you don't necessarily specialize in that if you're just in a regular business analytics and data analytics position, right? So it is totally possible that someone who doesn't have a data analytics background, but if they have really strong portfolio, that person might actually be hired. But I mean, the starting point, you're definitely having an advantage. So you just need to put in the effort to build a strong portfolio. Then it will work towards your favor for sure. But it's not a huge advantage in my opinion. Question from Brandon. I had an idea of making visual SQL charts, but I don't know how to do that. What are some YouTube videos you recommend? Oh, there are a ton of videos on YouTube. I don't think I can do that in this session, but I'd like you to maybe stay in touch with WeCloudData because I think in February and March we are launching free Python and SQL courses. And I think our free Tableau course is going to be available in April as well. So yeah, we will cover SQL, Tableau, a little bit ChatGPTs. There's some really interesting data sets you will analyze, and we'll teach you how to build dashboards as well. So stay tuned for that. And those are free courses. Is it possible to get all of these to our email? I don't get the question. If you don't mind, can you, rephrase your question? And question from Nilesh, any suggestions for some good courses to learn machine learning and data science? I think on Coursera, there's some, I think if you want to start with machine learning, Indran I believe he published these new machine learning course, right? So he had an upgrade to that. And the very old version was based on R, or maybe is it MATLAB, maybe, or Octave. But now I think the new version is based on Python. I would definitely recommend that. It's a great way to start your machine learning journey. So yeah, take a look at Andrew's Coursera course on machine learning. That's something I would recommend. And go to DataCamp. DataCamp has a lot of great resources as well. They have a lot of good Python resources, and their blog posts are really good as well. Do company look for data science related certifications from Azure, AWS, and GCP? Yeah, that's a good question. When company hire data scientists, I don't think they'll emphasize that much on like your cloud certification. But having cloud certification, I believe, is always going to give you some small advantage. But just keep in mind that like working as a data scientist, right? A lot of things are done in the cloud, but you're not really going to work with like the cloud infrastructure as often as you would have thought, because you're not really cloud engineer, you're not IT. In most of the businesses, like insurance, banks, it's pretty strict. Like everything needs to be set up by IT because data governance is very important. So even if you've done a bunch of AWS solution architect, developer certification, you can apply none of those in the bank. It's all taken care of by the IT, right? So what it means that if the company is using AWS to do machine learning, you're going to they give you access to a Jupyter notebook. So basically the environment switch from your laptop to a cloud environment, but you're still just working with Jupyter notebook, or you're working with Databricks, to write Spark code, right? So in that sense, I think cloud certification is not adding that much value. If you work as a machine learning engineer or data scientist in a startup, it's a different story, because startup is meant to move fast and fail fast and move fast, right? So companies, it doesn't have so many, processes. So most likely you will have access to have like more access to different AWS services. And honestly, I used to work for a startup as a data scientist. I did a lot of data engineering work as well. You have to set up everything yourself. Yeah, you have that freedom, and that's why you can learn really, really fast. But in those cases, I think companies don't require you to have certification. They'd rather look for someone who just learns fast. And then, yeah, those are not that hard to learn. But if you want to like become specialized in AWS, becoming a network or DevOps or cloud engineer, that's a different story, but that's different from data science. So I think cloud certification is not as important. But if you're talking about the AWS, like, data science, machine learning certification, I also don't think it's very useful, because those are just multiple choice questions. Like, unless one day these certification actually require you to complete some labs, which is hands-on, and that will make much more sense. If it's only multiple choice question, I don't think people, like, it doesn't mean people can pass those multiple choice questions, can actually build data science solutions well in real life. So yeah, certification is not that important. Just showing your work is the most important thing. From Lei, is it necessary to have personal portfolio on GitHub or participate in Kaggle before finding a job? This can go in parallel, but definitely upload your personal portfolio project to GitHub. Make sure it looks decent, right? You don't want to show messy code to a future employer. it's going to backfire. So have someone look over your code, right? Make sure it looks decent, comment the code well, have a markdown that a README that describe the project. And you always need to communicate like why you did this project and what did you do? What's the purpose? What's the goal? What problem you're trying to solve? Writing a project summary is definitely going to be helpful. Like I've recently just interviewed machine learning engineers for my own company. And I check out people's GitHub repo, and I looked at so many of them, and I was puzzled. Like, why? Like, most people don't really comment their code, and I go to like that GitHub repo. There's a README file, but it's empty. There's only one title. I really don't have an idea what they actually did. Instead of just looking at a Python script, you'd rather not do that. So yeah, that would be my recommendation. If you want to upload your code to GitHub, make sure that you do some code review and before you upload that. Working on Kaggle project, I would say you should always do that. It helps you improve your skill. And you look at many different types of machine learning problems. That's very helpful, right? But Kaggle doesn't necessarily help you get a job because I think most of the data scientists or aspiring data scientists will work on some sort of Kaggle projects, unless you can rank really well, right? Another shortcut is just, write blog post, project summary that people can actually read and understand. So that's something I would recommend. A question from Mauricio. Sorry if I mispronounced your name. Does deep knowledge of a field, such as having a PhD, help to land a DS job in certain industries, such as pharmaceutical and healthcare? I don't think so. But of course, it depends on the type of jobs, because if you work in the research lab in healthcare, that's probably important. I know, like, for example, for different banks, they have I think it depends on the HR policy and culture. Some banks that I know, they prefer PhDs, but some bank doesn't seem to be like really favoring PhDs over other candidates. I think it depends on the hiring companies, but to be honest, having a PhD is always going to give you some sort of advantage for sure, like especially for data science, because if you want to do really, really well in data science, you need to get specialized. You can't just know scikit-learn and expect to be the best data scientist, right? So having PhD tells people that you have really good research background, and you can learn things probably really, really fast. So, most of especially when you start to work on deep learning, that always involves like reading paper and implement some code. And that is a skill that most of the data scientists actually don't have. So I think you have an advantage. But if the question was about like, do you need to have knowledge, a very specialized knowledge about a specific field? Not necessarily. We did some corporate training. A lot of healthcare practitioners, these are like the data people in that organization. I can tell that not many of them have PhD, but all of them work on analytics. So I think it depends. But if you want to do deep learning, right, for drug discovery, 2 of our deep learning course instructors in the ML engineering program, they work for a drug discovery startup. They actually both have PhDs. So I think you will have an advantage if you're working for those type of positions. What do you mean by making SQL cool again? Are companies looking for more data scientists, analysts that are really good at gathering data from outdated on-prem infrastructure, move it to the cloud? So I think what I meant was just if you look at the data industry, it sort of has gone through several stages, right? In the past, and most of the data science and analytics, right, were done on-prem, right? Large database instances, SQL Server, Oracle, Teradata. SQL has been so useful and popular for so many years. But there's a certain period, like 10 years, when Hadoop and distributed system came out and Apache Spark, right? Companies start to shift their belief, right? Instead of just relying on SQL, which is good at analyzing structured data. Now, the reason why Hadoop and Spark became popular is because they are just built for analyzing large-scale unstructured data, such as textual data. And SQL is terrible at that, right? And that's why data lake, big data became more popular, right? All the companies are moving to the cloud, building their modern data infrastructure using, distributed systems, different framework and platforms. So sort of SQL sort of, lost its, appeal to many organizations, because you can use Apache Spark to write SQL queries. It's not SQL, but the syntax is very similar to do data crunching, right? But with the modern database, technology such as Snowflake, Redshift, BigQuery became popular, and as company moved to the cloud, right, modern data warehouse, become popular again, right? Company either go down the data lake house approach path, or they just stick with modern data warehouse. And if you work with Snowflake, then you'll be running a lot of SQL, right? But these are things that happens at the data infrastructure, data engineering level. I think for data scientists, they always need to use SQL to at least extract data, retrieve data from the databases, and do some sort of heavy lifting data preparation in database, and then you bring the data over to your data science environment, such as a Jupyter Notebook or Databricks Spark environment. Okay. Bargob, I have a PhD in machine learning, but my expertise in Bayesian deep learning, TensorFlow, but not in the data querying or deploying cloud servers. What would be your suggestion to me to start building a complete portfolio? Yeah, well, first of all, you have an amazing background, PhD in machine learning. Even without, I think, machine learning engineer, MLOps skills, your, resume is probably still very popular in the industry, right? I would recommend, learning some PyTorch because it's really popular right now. Yeah, PyTorch, look into computer vision and NLP. I definitely think you can find a machine learning scientist or MLE, a machine learning engineer job, right? But if you would like to, of course, upskill yourself, then yeah, definitely try to learn some data engineering skill, because working as a machine learning engineer is something I would recommend. And then in practice, data is not prepared for you. So if your company deal with large data, let's say large corpus of textual data, and you can't really use Python running on, a small server to solve the problem. A lot of the time, like the big data challenge is the first challenge. So you're probably going to use Apache Spark to do some sort of data parallel, processing. So getting familiar with Apache Spark, learning some SQL, because you can use Spark SQL to retrieve data from the data lake. So just spend more time and effort on the data processing piece. I think that's going to help you a long way. And then on the MLOps side, I definitely recommend, right, whatever deep learning models you have trained and built in the past, see if you can deploy that model in the cloud. Maybe pick up, Amazon Web Services, see if you can use Python, even, fast API, just to build some sort of, inference API. That would definitely help you. Learn some Docker, because most of the real life ML models are deployed in Docker containers. I think that will help you as well. But definitely learn more data engineer, ML engineering skill. That's going to make your portfolio or your profile look a lot stronger. But even with your current credential, like PhD in machine learning, I don't think you'll have a problem getting a job. If you want to get into big tech, then just do LeetCode. Many people don't recommend, but it's something you have to do if you would like to get into a big tech company. Yeah. Is it possible to connect with you over LinkedIn? Yeah, definitely. You can just search my name. There's a private question. What are opportunities for new grads? Data engineering position. There are a ton of data engineering opportunities out there. Well, you know what? Since we have just dropped the data engineering. Oh, tomorrow evening, I have a data engineering career guide. I'm gonna actually spend more time going through the actual guide instead of doing the Q&A. So yeah, so join that session if you want to learn more about data engineering. But I'll give you a quick rundown of this. 1 second, let me send you the link. Yeah, let me see. If you go to job market, I think it tells you that it's very different from data science. Remember, data scientist, 1 year, 1 to 3, it's like 13 to 18% for each year, right? That's like 50% of the jobs require like, you know, less than 3 years of experience. But for data engineer, 60% of them require like 3+, because typically when you read job description, it says like 3+ years or 5+ years, right? So that means companies want to hire data engineers that are more senior or they have more experience. Okay. For new grad, you still have a chance because unlike data science, it's a less competitive field. You know, there are not a lot of data engineering training courses out there. That means there are less talents out there. And this field is evolving so fast compared to data science, because with data science, right, you need to know SQL and Python. Then what's evolving is like the machine learning algorithms. You have new models, new algorithms coming out. You just need to adapt, but we still are just using Python and calling those packages, right? But with data engineering, there's so many different tools you need to learn. There's the modern data stack, right? There's, you know, data warehouse. Oh, so this is the curriculum, for example. This is WeCloudData's data engineering bootcamp curriculum. You need to know programming. Other than SQL and Python, you need to know Linux as well, right? Know one of the cloud platforms. You need to understand data warehouse, a bunch of big data tools, but knowing tool is not enough. You have to understand the process. How do you actually engineer a data pipeline? How do you ingest data? How do you work with connectors? A little bit data pipelining and containerization as well. And all of a sudden you feel like there's so many more you need to learn. Like with data science, you're using Python, but you work with different machine learning algorithms, and scikit-learn PyTorch is so standardized that switching to a different algorithm is really just changing 2 lines of code. But with data engineering, you feel like it's a lot more effort. But the good thing is that if you know these tools, even if you're a junior and you're new grad, companies are hungry for your skill set, because there are just not enough people knowing all of these. So that could be, you know, your lack of real life work experience might be a disadvantage, but if you know all of these tools, it will be, you know, a big weapon. So yeah, you just need to keep learning more, I guess. Feel free to read this guide. From Anna, what is the best tool or platform to present your ML deep learning portfolio? That's a good question. So first of all, I would say I would recommend data scientists and engineers to start building their personal brand, right? Even if it's just a LinkedIn post or a Medium blog post, I think this will be very helpful. It also sort of helps you document your learning process, right? You're just sharing your knowledge, and people always appreciate that. One example I can give you is that I think back in 2019, when our students start to like work on their web scraping project in the data science bootcamp, one student wrote a Medium blog post about phishing. It's actually a group project, so they scraped some phishing website, and yeah, I remember 2 students, right? It's a group project, and one student got inquiries from startups in Silicon Valley, and just like approaching her on LinkedIn and say, hey, are interested in having an interview with us. Another student presented this project in the final round of interview, and to the vice president. I think he got hired by Nestle. Yeah, and that VP was a fish and lover as well, so they hit it off really well, and he got the job. It's probably not the only reason that he got hired. It definitely helped in some way. So yeah, Medium blog post, start building your personal branding. Check your code into GitHub. Make sure you annotate or you add description, right? A project summary. I think these are good enough. I've seen people, going an extra mile to build even a dashboard to interpret their machine learning model. I feel like that's really cool. You can deploy the machine learning models using, for example, Streamlit, which is a Python visualization or Python web app, data science web app kind of package. And you can deploy that in the cloud. So you can share that link on your resume, and so people can click on it and actually see your portfolio project or whatever visualization. For example, if you build a ChatGPT chatbot, can you deploy that in a web app using Fast API, for example? I think that will be impressive. If the job requires Python, SQL, machine learning, I think in your portfolio project, you definitely want to show more, because there are 100 competitors out there, 95 of them will have Python, SQL, and machine learning skills on their resume. You want to stand out, so you want to show more. You want to show Spark, you want to show AWS, and these are the things that will help you stand out. It's more work, it's more effort, but I think it will be worth it. Question from Jorin. I have a background in mathematics, PhD in algebraic geometry, but I am not as familiar as applied math, computer programming. I am learning Python, SQL, which is great, and starting to post projects on GitHub. Yeah, you're on the right track. Do you have any ideas for leveraging what on math experience I do have to look good in data science? If you're really good at math, I would recommend writing some blog post, because I think when it comes to applied data science, most of the time people are just calling Python packages. The data scientists don't really write or develop the algorithms themselves. We're just leveraging a standard package. But I think employers will always appreciate people who can explain math really well. It's because most people just can't. They know how to call the packages. They know how to follow a standard workflow to solve practical challenges. But when it comes to tunings, actually doing very well, or whenever you run into some sort of challenges, I think people with a stronger math background can always do better. So see if you can write some blog posts to explain tough deep learning, machine learning problems, and I think that might help. Again, that comes back to building your personal branding, and that will set you apart actually from other people. So like for example, if you're into deep learning, you might want to read the deep learning book, right, by Joshua Bengio, and there are a lot of math details in it. That could be a good starting point. Yeah. Do you have recommended SQL course? I would highly recommend WeCloudData's free SQL course, but you'll have to wait till March. I think we'll launch it very soon. But I think Udemy has some good SQL course. Definitely check out DataCamp. That's something I would recommend. Yeah. Any recommendations for good practices when it comes to time series forecasting? Any specific kind of models in your experience that work really well for seasonality trend? Just as a starter, I think you can look into the Facebook profit. It's some sort of regression algorithm. Look into the traditional time series forecasting methods. Sometimes they just work better than the deep learning approach. When it comes to deep learning, I think sequence to sequence models, LSTM usually works pretty well. But yeah, try some deep neural network approach. We worked on some practical projects and we tried both, and it seemed like the traditional approach that just works better. But it could be the scarcity of the data. But yeah, but I think nowadays you should always try a deep neural network for seasonality analysis. In some cases, it definitely works really well. What are some of the opportunities for new grad data engineering positions, and what areas do you recommend to upskill in this time? If you're talking about data engineering, I think there, well, let me see if I can find it. Oh, the learning path. Yeah. So I think you should be focusing on a few things. The data engineering specialization, one is analytics engineer. So these are the engineers that are really good with SQL and data modeling. So dimensional modeling, data warehousing, star schema, building white tables. But that requires the understanding of end-to-end data ingestion, data modeling, and data warehouse, right? So you're going to use a lot of SQL and use dbt to, to orchestrate a workflow, create models and things like that, and macros. That's one area that's quite exciting. It's not that company haven't done this before, but these are modern tools that works really well. And that's one direction. And big data engineering, that's the second direction. So this is the data lake, Apache Spark, Lakehouse, like the path, right? So understanding distributed system, data lake, Apache Spark, Presto, Trino, how to work with streaming data. I think this is quite exciting. And of course, if you know all of these tools, I believe the salary is definitely going to be higher than analytics engineer, right? And of course, another area is just the traditional data integration pipelines. And these are the data engineers that you can come from traditional ETL background, just learn some modern tools, understand Spark is really important, using Airflow, Daxter, Prefect to orchestrate data pipelines, understand data quality and governance. There are lots of jobs in ETL and ELT as well. So these are some of the recommendations I would have. I would give you. Yeah. Does MBA in business analytics could be used to shift into data science? I think so. There's some, like most of the MBA programs nowadays will teach some sort of predictive modeling and data science as well, right? So if you have MBA in business analytics, I think, oh, sorry, I didn't finish that. Some universities offer 4 courses focused on analytics like quants in our and other deep dive courses. Oh, so you're asking whether an MBA is worth doing. Okay. I don't know which area you're from, but let's say I'm in Toronto. We have like there's a program from Queen's, has the Queen's MMA. So that's management analytics, right? A master's program, kind of similar to MBA, but it focuses more on the analytics side. So I heard that it's a decent program. It's not as hands-on and practical as the boot camps, like the ones offered by us. But I can tell you, like students, when they graduate, the placement rate is really good because, they usually have really good hiring partnerships, and a lot of companies will, yeah, because when it comes to data science, companies still believe in, like the traditional business still believe in hiring people from, MBA, a master program in, analytics, right? Because they think people are all coachable and you can always get hired, and they put you through training, and then you can always learn the technical stuff. This kind of programs touch on, like, a lot of the AI machine learning stuff. It's just like there's so many things they're trying to cover. You don't get really specialized. But you're paying the 70 grand tuition, and it's definitely going to help you because the alumni network is so great. So yeah, a lot of people will. I have friends who went through that program. He's been doing analytics for many years. He always wanted to be promoted to manager, and he ended up doing this program, and he got promoted. So I think it worked out. So yeah, but the tuition is pretty expensive. I see that links related to data science doesn't have Golang. Any reason, or it's just not popular enough? Golang, Rust, and these are definitely great languages. Um, we plan to cover Go in our DevOps program. It's not that popular in data science yet. Um, isn't there another programming language called Julia, which is more popular in data science, I think? Um, yeah, I just think the market is just not ready for that yet, for those kind of languages because of the ecosystem. Um, but it may change in the future. But Python is definitely the king right now. Even though Go is a lot faster, more scalable, right? Kubernetes is built in Go. It works really well in distributed systems, but it's just not the best language for data science, I think. And I see some potential in Rust doing machine learning. I see some open source projects around that. But I think the reason is just because there are too many choices when it comes to data science. And a couple of years ago, there was a big war between Python and R. So people just, I guess, if you were to think about Go, like people would rather choose R, I guess. But R has a disadvantage, which is like it works really well. It serves very specific purpose, which is statistical analysis, machine learning. And some R packages and libraries actually runs faster than Python. But unfortunately, Python is a more formal programming language, so it can be used to build applications and APIs as well. So when it comes to ML engineering, for example, or even data engineering, Apache Airflow is written in Python. There's PyTorch, and of course they support R, but it's not the first thing that people think of, right? And so it's really just the community. It doesn't really mean Python is absolutely the best when it comes to like building machine learning models. And that's why in production, right, a lot of times, if company use Java, C++, and you have to switch your Python models to different kind of format, and Onyx is a really, model format, packaging format in that case. So you can build models in Python and in R, and you can package that in a way that it can be directly used in Java programming language. So you can use that in production. Yeah. Can you also give some insight on writing cover letters for machine learning engineer positions? Okay. I'm not a big believer of cover letter. It's simply because you just don't have the time. I remember a month ago, I posted machine learning engineer job on Indeed and LinkedIn. And I got like 400 applicants. And I was a little bit slow because, I have so many things we need to work on every day. So it took me a month before I start to look into it. So I went to Indeed, and then there are like 400 applicants. And there's just so many resumes I need to go through. I don't have the time. So, in that case, because it's a more specialized role, right? So, in our company, then I'm the person to review these resumes. It took me a while, and then I start to like just skip resumes. So I definitely didn't even read any cover letter. I just go straight to the resume itself, and because I'm pressed for time, I'm just looking for the key information. I want to see experience, or if you have the right keyword I'm looking at. That's very typical, right? And then experience is probably more important. Whatever that's on the first page, that's what I'm looking at. If I'm interested, I'll move on to the second page. So yeah, I don't think cover letter works when you it's still useful to have a cover letter. I don't think it's going to play a very important role in job search. Like if you apply online, it can be useful for cold calling. If you reach out to people on LinkedIn, and of course the format is not in a Word PDF document, but it's your LinkedIn connection request message, the way you introduce yourself, or after people connect with you, the first message you send out. I think this is sort of like, your cover letter when you start to socialize and network with people, and that is important. And my recommendation in that case would be, if you're networking with people and most of the people you're interested in connecting with, they're probably busy. So in that case, you need to provide some value, right? People don't really expect you to provide like real value, but provide them something that's interesting, so they actually will want to take a look at, right? For example, if you have a portfolio, you have a blog post, in this case, plays really well. You can share a blog post with people and just ask for their opinion. And sometimes people share their portfolio project link with me. I'm actually more curious to click on it because somehow I just want to click on it. And I feel like I'm curious. I just want to see what this person has done. But a lot of times, even after I looked at it, I still don't, I don't have time to respond. But if I find something that's really interesting, I may actually reply. Yeah, so I think this might be helpful if you can share your blog post and ask for people's feedback. I think people are much more willing to give you feedback if you're asking for their professional, right, suggestion. They're more likely to respond to you because a lot of people actually are willing to give back. But if your intention is, hey, can I connect with you? I would like to expand my network, or can you help me find a job? This kind of message is usually not very helpful. I'm looking into starting to build my portfolio with portfolio projects. Do you have any suggestions on what kind of projects would stand out to businesses? Yeah, so if you want to get into, let's say, insurance, I would recommend just pick this domain and then go do some research on different use cases of how insurance businesses apply data science and machine learning. I think you have to understand that first. Try to understand the use cases first, right? And then the next step would be just go find a data set. This is where Kaggle can be useful, and pick a data set from Kaggle and start to build, some sort of data science models, and then write a blog post about it. Always try to focus on the business side, and because I think companies care more about how you're going to apply your model. Can your model actually generate business value? Like finding people who can train the models, there are a ton of them, and ChatGPT can write the code for you. So that's not the real value of a data scientist anyways, right? But I don't think ChatGPT can reason. It's just a large language model trained with some sort of reinforcement learning. So to be able to reason, that is very hard. So I've worked with data scientists and engineers who are really good at just writing code, but when it comes to actually analyzing things, you'll find that they're actually not very good at it. So just keep this in mind. Okay, someone would recommend McGill's MMA. I definitely would look into that. Yeah, because I'm based in Toronto, so I heard more about the Queen's MMA. But McGill is an awesome school. Yeah. There's a question from Kent. The first resume received always get the most attention. Ken, what do you mean? Do you mean people who apply first, or do you mean you submit your resume multiple times? Oh, okay. Not necessarily, but so it depends, right? So I remember one of my friends at another company, a startup, they posted a job, and it's posted by their recruiter. a data scientist job. They ended up hiring one of our students, but they posted jobs. And in the morning, right after he posted the job, like in one morning, he received like 60 resumes. And I remember my friend told me, because she was the hiring manager, and she said, the recruiter just turn off the ads, because to post jobs on LinkedIn and Indeed, they have to pay, right? And he felt like he got enough resume. So he just paused the job and he started to look into that. So in that case, applying as soon as possible definitely helps. But in my case, I waited almost a month before I had the time to look into all of those resumes. And my plan is just to go through that today, and I need to finish them. I didn't go through all the resumes, of course. But in that case, I feel like applying first doesn't really help much. But in general, I would recommend it, like, yeah, apply sooner. That's probably better. It really depends on when people will be looking at those resumes. Are there any in-person events hosted by WeCloud in the near future? Workshops? We do most of the workshops online. So just so you know, I think Monday is going to be our data engineering nights. I think Wednesday is usually DevOps. Data science will usually be on Thursday, and Friday will be WeCloudOpen workshop. So we have invited speakers, and workshops tend to be more hands-on, so you can actually learn something. And yeah, join our Discord channel, because we're launching a bunch of free courses. Yeah, but in person, I guess it depends. But I think our audience is from all over the places now, so we just prefer to run everything online at this point. Is it hard to transition from data analyst to data engineer? Depends on your skill set. I think going from data analytics in general to data engineering, that means there are a lot of tools you need to learn. A good way to switch to data engineering would be analytics engineering, because working as a data analyst, you do business intelligence, build dashboard, you're really good with SQL. So in that case, yeah, that was actually my recommendation in this career guide. Let me find it. I think at the bottom somewhere, we have some suggestions for people from non-tech. If you want to switch to data engineering, we talked about some of the challenges and also recommendations. And if you're from IT, I think I did one session a while ago, talking about switching from IT to data engineering. And I had some suggestion here for people coming from support, DBA background, from traditional ETL background, and even software. Yeah, look into that. So I guess my answer to Jonathan, I think it's not that easy, but you can totally switch from data analytics to data engineer. Data engineering requires a lot of tools and also experience, right? But when you compare that to data science, like, you don't really need to learn that much math. It's just like, if you put your effort into learning all of these things, you will become a data engineer. And you need to be very good at like self-paced learning, and keep upskilling yourself, because this field is changing fast. I remember a couple of years ago, we did a lot of workshops on Apache Spark and even Hadoop and stuff, but now things are changing. Modern data stack. Spark has been evolving as well. Databricks is not only offering Spark, but they provide solutions, right? Now they even have like Pandas data frame support. So yeah, things are changing quickly. And now people are going from data lake to lake house. So you sort of always need to stay, up to date with the latest trend, and then you will always stay competitive. for many data engineers, that's actually the quite exciting part of being a data engineer, right? And for software engineer, it could be more exciting to learn different system design, different, programming languages. But you're always like, you get excited about building different kinds of applications. With data engineer, things are always changing, moving from on-prem to the cloud, right? And building, real-time systems and stuff. So it's quite exciting time for data engineers. And this part is really hard to automate. Companies are all using similar tools, but automation is very hard for data engineering. So there are low-code platforms for data engineering, but you definitely need data engineers to be able to, because I think the complex part, or the part that's harder to automate, is the business rules. You can have two banks using exactly the same infrastructure, but the way they built their business is different. That means their systems are very different, even though they're using the same tool. So you can't really completely automate that. If you automate something, made a mistake, because it's all being automated, you might be losing tens of millions of dollars just for that. So yeah, it's you have to pay a lot of attention. When is your workshop for data analytics? It's usually on Wednesday. You know what? Let me show you Discord. This is our Discord channel. Oh, I see some people joining. So yeah, so on the top, you'll see events, right? So in the future, all the events, for example, tomorrow we have data engineering career guide. So you'll find the registration link here. Or sometimes we send emails to everyone to remind you about upcoming events. So they're or we always post a link before we start the event on Discord. Yeah. Oh, sorry. The link for Discord, it's in my Notion page here. Let me send you again. Yeah, so here we have the Discord link, our YouTube channel, and the career guide. Okay. I've been getting OA and first interviews from applications, but it seems hard to compete with CS background applicants. I think, John, I think if you're getting interviews, it's a really good sign. That means your resume is definitely very relevant. In this case, I think what you need to improve is, I think there might be two scenarios. One is you need to improve your interview skills. It is a different set of skills, right? Another thing you can improve potentially, because I don't really know, but we're gonna have some sort of open office hour on Thursdays going forward. Yeah, there will be a bunch of announcements we're gonna make. But I think Thursday during lunchtime, we're going to offer this type of casual chat, and you can bring your resumes. We're happy to help you review your resume for free. So drop in. We're gonna announce that on Discord. But yeah, back to your question, I think it could be related to the project or your experience, because if you have worked on portfolio project, company will definitely ask you about oh, sorry. Yeah, you had first interview. Yeah, so they probably ask you about the projects and skills. Probably it doesn't impress people enough, or you didn't go too deep, because people will always ask you like what you did, why you worked on this project. They ask a lot of follow-up questions. I think maybe it's a matter of preparation. I don't think, CS background will always have a huge advantage. Yeah, I hope you can be more confident. It's sometimes preparation, and it's just sometimes it could be like just working on more projects, or maybe getting some sort of mentorship and support. Just go talk to your friend who work in this field and ask for some advice. I'll be happy to look at your resume if you can join some of those WeCloudOpen workshops, or office hours. Yeah.